Yeah, so we'll go ahead and start the class now. I'll start sharing my screen. Can everyone see my screen all right? Okay, so for today's class, we're gonna go over some basics of how CPP works. We're gonna go into two new types of variables, strings and doubles, and then we're gonna go over some Boolean stuff, which is another type of variable. And from Booleans, we're gonna go into some if statements, some conditional operators, and then at the end, we'll go over homework. So let's start off. So after the first lesson, some of you guys had some requests that we go over some of the technical aspects of how C++ works. And I think that's extremely important, especially as we're starting to learn a language, as an intuitive understanding of the background of how language works really helps us write better code and implement better policies. So as many of you guys already know, C++ is a compiled language. Um, it's different than other languages such as Python, as C++ needs a dedicated compiler on the computer. This means that the language has to go through a specific process to produce a result that we can see on the right side of our screen right here. So first that we do is that we write a source file, like a .cpp file that we see right here. So this source file can have all your code in it. It has all the header files. It has essentially what you're writing is your code. Then there's a preprocessor that takes all these header files, such as the hashtag includes, and makes an object file which includes all the hashtag includes, essentially removes all the headers and turns it into a little bit more little simpler code. And then there's a compiler that you install on your computer that takes this object file, turns it into binary that the computer can understand, and then turns it into either a library or an exe executable file. So, for example, on REPL, when we run this program, it does all that for us within the server that they host, that REPL hosts. But if you were to do it on a computer, you would have to download a compiler, and the compiler would do all of this for you once you execute the proper command. Okay, so that's just a little bit of the intuitive background behind C++. Um, I thought that'd be really, really helpful for us, especially if you start diving deeper into the nooks and crannies of C++. So, as we stated last class, we would go over strings. So, for strings, it's not really that necessary, but you should include the string header file. It allows us to do a lot more stuff with strings, and I think it's extremely essential, especially when we're doing a lot more like string concatenation or type conversions. So we'll go into what a string is. A string is a variable, just like an int or a double or a boolean, that stores sequences of characters like letters and sentences. It's extremely useful. And so the first thing we should obviously do when we're dealing with strings is to include the hashtag string, the header file. And then, similar to ints, as we stated last time, a string must first be defined. So we can just do that right here. Declared. So we can just do string A. That's an example of it. Do string B. We can do string C. Alternatively, we can also do string A, B, and C. We can define all three strings on the exact same line. Now, a string really isn't useful unless we actually define it or give it a variable, or give it essentially a definition. So we can say, I'll comment this out. We can say A is equal to hi guys. B can be equal to how are you doing. Oops. And then C can equal I'm fine, thank you. Now note that all the stuff that I put in the string was all contained within these two quotation marks. If I didn't, then the computer wouldn't recognize this as a string, and we would get an error. As you can see right here, it says they expected a semicolon, they expected this. But the second that we add these two quotation marks, it turns it back into a string. See, and nothing's out here. And then extremely similar to integers, we can do both of them on the exact same line. So you can just define a new string called string j and set it equal to how is everyone doing. and then it accomplishes the exact same task. Now, note, when we outputted strings earlier in the first lesson, we went ahead and just used cout, and we just outputted the string. For example, how is everyone doing? Right? But what strings allow us to do is that we can just output this how is everyone doing just one time with one thing. So if you just output the string j, it accomplishes the same task. So we run right here. We'll see two of the same things. How's everyone doing and how's everyone doing? Yep. So what this allows us to do, instead of typing the same strings over and over again, for example, if you're doing, let's see if you're asking 10 people what their name was, instead of saying cout what is your name, and then what is your name, what is your name, you can just put cout j or cout the name of your string. That allows you to do it multiple times, much faster. And then extremely similar to ints, redefining is extremely useful. For example, we said string j is how's everyone doing. Alright, now let's say we want to change the variable as j. Just simply redefine j. Go from how's everyone doing to say I'm doing well. What about you? And then go ahead and use the same string. Output the exact same string. It should give us a different value. So you look on the right side. We'll go from how's everyone doing, and then goes and redefines j right here. I'm doing well. What about you? And then goes and prints it out right here. Okay. So now that we've learned some of the basics about strings, we won't go much into like typecasting and a lot of this complex stuff. Now that we know some of the basics about strings, last class we simulated a conversation between two people using cout statements, correct? Now this time you can use it using strings, suggested right here. So now for your guys' task, you guys can do the exact same thing, except let's try to make it a little more complex and have more lines. Try to redefine strings while we're doing it. We'll give you guys about 4 minutes to do this. So it's been about 4 minutes. So let's go ahead and start solving this problem. So I'm going to start defining a couple strings. I'll do string intro. It'll just be defined as hello. And I can have a string that says like a question, a string q, and set that equal to how are you doing today? And then we'll have another string as a, let's say, response, and say I'm fine. Fine. Then we'll have a string what about you? So we can just say string w. We'll say what about you? And now, since we have a couple of strings ready, go ahead and solve this. We can see out the intro, and then the other person will respond with the intro back. And we can go ahead and add a space, and we can ask them the question. And then they can be like, I'm fine. And then they can ask them, what about you? And they can respond the same answer with R. So if you go ahead and run this program, yeah, hello, how are you doing today? I'm fine, what about you? I'm fine. So that's a pretty simple conversation that we manipulated some strings. We didn't really redefine it, but we could have if we wanted to. So now that we've learned some of the basics about strings, some of the more advanced parts will come later, such as like the string.size. We'll cover these after a while. So now we're going to an extremely important type of variable, and these are called doubles. So doubles are extremely similar to integers, just they allow for decimal places and they can perform calculations with decimals. So again, very similar to integers and strings. You first have to declare a double. Go with double A, or double B, or double C. Now this actually might pose a problem because we defined a string called A, B, and C, and a double called A, B, and C as well. So for all future reference, please make sure that all of your variable names do not contradict each other or have the same variable name. So for this purpose, we'll just go with X, Y, and Z. I don't think we've used X, Y, and Z yet. Or of course, you can define it all in one line. Declare them all in one line. X, Y, Z. And then you can go ahead and define them now. You can say X is equal to 89.056. Y is equal to 78.097. And Z can equal 98.1. So the thing about doubles is that they allow us to use decimal places and do calculations with them compared to integers. Integers will not allow us to use decimal places, and if you do any calculation, it will truncate the digits, the decimal places right after the decimal point, so you'll always end up with the whole number. And similar to integers, similar to all types of variables, you can go ahead and just do them all in one line. You do like a double H, you'll do 3.14. And then just like integers, we can use the fundamental operators on doubles. So you can say, create a new double right here. Let's do double Y, and we just use Y. Let's do double, let's say double E. We can just say E is equal to the sum of X and Y. So we output E. We should get an answer of 167.153, which, yeah, that seems right. And then, of course, we can do subtraction. We can do E is equal to Z minus Y. And we can go ahead and output that. There you go, we got 20.003. We can say we do multiplication. E is equal to h times x. You can do division. And now, with especially with double division as compared to integers, again, we'll have the decimal places pop up, unlike the integers. So you can do e is equal to y divided by z. Sorry, y divided by z. Now, one thing to note right here. Let's say I have a double e, and I've int let's say int first, we set that equal to 89, then int second equal to, let's say, 54, and even int ed, right? So we set ed, so right here, we set ed is equal to first over second. We would get the answer of, we would get basically an answer without the decimal places involved. Looks like my REPL isn't working. Okay, well, we can come back to this on a different time. But one thing to know about doubles is that we won't be able to do mod. We won't be able to do mod with doubles because mod only works with integers, and changing data types will not be for this lesson. So now that we know just a little bit about doubles, you can go ahead and ask a customer how many toys, shirts, gallons of milk, and shoes they want, and then their prices. And we can go ahead and calculate their total price. So the task is right here, and we'll go ahead and solve it in, let's say, 5 minutes. Okay, so it's been about 5 minutes. Let's go ahead and try solving this problem. So this one, we'll go ahead and start using some CIN as well. So we'll go ahead and we'll ask them first, how many toys do you want to buy? Right? And then, so first I have to create some integers for that. So let's look at an integer. Actually, we'll just use a double for now. And we'll say number of, so NO, and then we'll say toy, right? And then we'll need double number of shirts, double of milk, and a double of the number of shoes. Remember, doubles can also store whole number values. They're not only restricted to decimal points. So we'll go ahead and input that to a number of toys. And we'll ask them, we'll go ahead and just copy this. I'll ask them how many shirts do you want to buy? And then we'll send that in to a number of shirts. And we'll ask them how many toys, shirts, gallons of milk do you want to buy? And then we'll go ahead and send that into number of milk. And then we can ask them how many shoes do you want to buy? Right? So remember, shoes are like, I'm referring to pairs of shoes. So like a box of shoes. So now we have the prices of the stuff above. So we can just do double. Let's do P with all of them. P toy, P shirt, price of a milk, and price of shoes. Right? And then we'll set them equal to their values. $10.90, $2.36, and shoes are $78.98. And now we'll create another double called the total cost. We'll do double total cost. And now you have to use some multiplication and addition here. So for example, if someone wants 5 toys, so the total cost will be 5 toys times the number times the price of the toy. So we can do this by using P toy, right, times the number of toys. And then you can go ahead and just add all the respective ones. So we can just do P shirt times the number of shirts plus P milk times the number of milks, and P shoes, the number of shoes. And then we can just go ahead and output this. Just say cout your total price is, let's output total cost. So you go ahead and run this program. Right here, how many toys do you want? Let's say let's say it's Christmas time. I want to buy 78 toys. How many shirts do you want to buy? Let's just say 12. Gallons of milk do you want to buy? Let's say I'm going to bake a lot of cake, so 23. How many shoes do you want to buy? Let's only say 5. So total cost will come out to $1,000, $1,288.22. So I hope everyone got the gist of how to use doubles, use some calculations with it. Essentially piecing together C in, C out, some operators, some doubles, and just some basic math. So now you have I'd say a decent understanding of how doubles work, how strings work, how integers work, and inputting. We're gonna go on to probably the most important part of C++, and that will be booleans. So booleans are a data type that can only take up two values. One is either true or false. True is represented by a 1 or a 0 by false. So for example, if you outputted 5 is less than 7, right? This is the symbol for less than. 5 is less than 7. It should give us a value of 1, right? Because that's true. So if you look down here, it should give us a value of 1. Really quick, I'm going to go ahead and comment some of this stuff out so you don't have to go through all of it. Uh, okay, yeah. So we go and run this, we should get just a value of 1. Of course, it's comments. No, I don't like warnings that much. There you go. You got a value of 1. Now, just as we used this less than symbol, we can also just flip it to greater than. So you get a value of 0, because obviously 5 is not greater than 7. So essentially, we just created a boolean. Now, there's a lot of different operators that we can use with booleans, but just remember, similar to all types of variables, you can go ahead and declare them, bool A, B, C. I'm not going to do the other way because we've done that multiple times. I'm going to define them, A is equal to true. And remember, unlike strings where you have to put them within quotation marks, C++ editors and IDEs and compilers just take the word true. A is true, B is false, C is true. Remember, they can only have two values, A or true or false, right? And then, of course, you can redefine it. Like we can just see out the value of C, and then we can just C is equal to false, and then we can see out the value of C again. I'm gonna run this program, get 0, 1, and then 0. So just as we use this operator to find a boolean, there's lots of other operators we can use. These are called conditional operators. So this symbol right here, not too long, this symbol right here is called the equivalence operator. So this checks for equality. Now please note, these are two equal signs. One equal sign, as shown here, is set to define variables and to give values to a data type. This, the double equals, is just meant to check for equality. So for example, I can go ahead and put this right here. Checks for equality. So if I outputted 8 is equal to 8. It should output as true. Look at the very bottom. Yep, we get the value of true. Now if we outputted, let's say 8 is equal to 9, it should give us a value of false. There. Now that checks for equality. There's also the not operator, which is just an exclamation point, which basically opposites everything. So we can combine this with, so the not operator, again, we can just do for example, not true would give us a value of false, not false would give us a value of true. So you can combine this with, the equal sign, we get the not equal operator. So see out, the output 8 is not equal to, say, 18, it was a value of true. If you go ahead and run this program, get a value of 1. But if, of course, if you set it equal to 8, we'll get a value of 0 because it's false. And just as we use the less than equal to sign, right? So this is the less than. We use it above. We can also use this one, no, greater than. So you can just do cout 98 is less than that number, which of course it is. But if you flip it, we'll get the opposite answer. Again, that's false. But if you use the not operator right here, you can actually flip that again. We showed that not false gives us a value of true. This is definitely false. It should give us a value of 1. There we go. So we can, since we've combined the not operator along with the equals operator. You can also combine this operator, the greater than or less than operator, with the equal to operator. So we can do cout is 98 greater than or equal to 57. And of course, it should give us an answer of yes. Why does my repo freeze up? Okay, we were down here. Yeah. So if you outputted 98 is greater than or equal to 5. Oops. If you output 98 is greater than or equal to 5. That's true. But again, since it's greater than or equal to operator, you're just going to put in 98, and it should again give us a value of true. Now this is equal to greater than or equal to, and then similarly, you can do this operator less than or equal to. Please remember, I've had a lot of troubles with this. Forget which side the equal sign goes on. It's always the right side. It's always the less than or greater than operator. Then it's the, you know, the equal to operator. So if you can do an example for this as well, um, put them in right here. Do, for example, 5 is less than or equal to 9. That's true. 79 less than or equal to 78. That'd be false. Look at the last two ones. We'll get a 1 and a 0. Okay. So now that we know a little bit about booleans, you don't necessarily have to use the variable form of it. You can just input it right here. We're going to do some inputting and checking for booleans. So we're going to input two numbers and evaluate whether the first number is equal to the second one, greater than the second one, if it's less than or equal to the second one. So we'll do it live solve for 4 minutes. I don't think I explained that really well, but the wording's right here. we'll go ahead and solve this in about a minute or so. Okay, so I think it's been enough time. We're gonna go ahead and start solving this. So I think someone in the C++ questions use doubles. I think ints would be fine in this instance, especially as I didn't specify. But doubles would be fine as well. For now, I'll just use ints. So okay, two ints. I'll call it first number, first num, and second num. And then so first we're gonna check, we're gonna output whether the first number is equal to the second one. So first num with the second num. And then we're gonna evaluate if it's greater than the second one. First num greater than second num. And if it's less than or equal to the second one. See out first num less than or equal to the second num. And that's it. If you go ahead and run this, I'll wait for us. We'll wait for two numbers. We'll put in 4. Oh wait, totally forgot. Before to input two numbers. I'm not gonna have any prompts for the user, especially since I know it's us. We're doing it, but it'll wait for us essentially. Let's put in 78. That's the first number, and 987, second number. So it's not. Is it equal to? Nope. Is the first number greater than the second one? No. Is the first number less or equal to the second number? And yep, that's right. So note that you could have used an exclamation point in this value. That would have also worked, except you might have gotten a little bit confused. And it might have given you a different value. Let's do 78, 987 again. Yeah, but essentially it's the same thing. So I find it, just always going to straightforward path. So now that we know a little about Booleans, we can in this format. You can also have done this in a similar format. You could create three Booleans. Call it bool equal to, less than, and greater than. I'm not really using Camel Case right here, but actually I'll use Camel Case. Always use Camel Case. It's much better. Camel Case is essentially if you're defining a variable name which has 2 words in it. The first word always is lowercase, and then the first letter, the second or third or fourth or the consecutive name should always be capitalized. So we can say equal to, just equal to first num equal to second num, and then less than this, and then greater than this. Looks like I forgot to put parentheses on these. And then we can just go ahead and output these 3. About cout equal to, less than. Wait, what am I doing? And then greater than. Gonna run this. We'll get all of them on the same line, of course. We'll do again 78, 987, and then we'll get 001 and then 001. So now we'll come to, we just use booleans, just telling us what number is greater than. But booleans can allow us to use what's a thing called if statements. Now, if statements are essentially the building blocks of writing complex code that can actually perform a lot more stuff than just evaluating whether a number is greater than or equal to or less than a number, or doing simple arithmetic operations. Essentially, it allows for code to be more useful. So I guess I can make an analogy. If you have a wheel, you can roll a wheel down a surface, you can make it do work. But if you add a wheel to like essentially a car with an engine, you can accomplish a lot more. So the syntax of an if statement is pretty simple, I'd say. You have if, you have a condition in here. Now this condition is like any one of these. Like first less than or equal to second or you can just where you can define as a boolean and put in a boolean right here. If the condition is true, then a set amount of code that you can write in here will operate. If it's not, if the condition is not met, it will skip over this entire if statement. So again, the condition uses a conditional operator. We just learned to accentuate a task described in the curly brackets. For example, if 5 is less than 7, then we could see out 5 is indeed less than 7. And then of course end line. So if we ran this, go ahead and comment this out. So if it runs this, we'll say 5 is indeed less than 7. I'm going to comment some stuff out here as well. Okay, so if you're going to run this, we'll just say 5 is indeed less than 7. Yep, that's what we expected. So we can go ahead and use this. Like this is again really useful, but that's like having a car without a steering wheel. Now, if you add a steering wheel, which is essentially an else statement, we can accomplish a lot more. So if 5 is less than 7, it would be like 5 is indeed less than 7. But what if it isn't? We don't know like what would happen instead. For example, if a student has like below a C, we don't know what his grade actually is going to be. So another addition makes this a lot more useful, and that's called the else statement. So if else statements have, sorry for the spelling, I'm really bad at spelling, but their syntax is essentially this: just if condition, then code, else other code. Note that the code has to be between the curly brackets, as it won't function. You can always, you can have the curly brackets within, but I always recommend using curly brackets. It makes code a lot easier to read. Putting else on a different statement makes it a lot easier to read. So, for example, we can create an integer. Let's say I have an integer h is equal to 9, right? And then so if h is less than 10, then we can output cout h is less than 10, and then end line. Or we could say, if it's not less than that, it says cout h is greater than 10, right? Five is indeed less than 7, and h is less than 10, right? If you're going to change the value of h to that, I would say h is greater than 10. Now, you could have flipped these two. You could have said if h is greater than 10, then you could output it this. And if it's less than 10, you could have output this. It'll give you the same thing. You just have to make sure that your if and else statements align. For example, if you had h is greater than 10, if you outputted h is less than 10, that would make absolutely no sense. H is greater than 10. Now, we can also go one step further. This is pretty complex, but I think all of you guys can get a hang of this pretty fast. So the structure is like as follows: if condition, then code, then else if another condition, then we have more code, and then you can have an infinite number of else statements, no, dot dot dot, and then finally the else statement, the final code. Now the thing to keep in mind for else if statements is that you have to make sure that the else if statements go in a proper order. Like I'll explain in a second. So let's say that you were checking for a student's age if they're allowed to ride a roller coaster. So their age is equal to, let's say, 15, right? So if you want, so for example, let's say we wanted to say if their age is less than 55, they can ride the roller coaster, and if their age is less than um like let's say 12, then they have to ride with the parent. If their age is less than 4, they cannot ride at all. So if you can do that like this, age is less than 4, then see out no, right? And then if it's between this age, between 4 and 12, age is less than 12, then see out with a parent. And then finally, um, if their um, age is less than, let's say, 55, see out yes. And then if they're above that age, then of course output not safe, too many jerks, right? So if you go ahead and run this program right here, it will just give us the value. Oh shoot, I forgot an integer. Yeah, it'll give us the value of yes. And then of course you can tweak this program to say like 98. And then it'll obviously say no, it's too unsafe. There's too many jerks. If it's like 4, so let's say he's only like 2. Like no, right? Now, the way that this if else statement, if else else if, this else if statement is, structured, it's structured in a way that it would make sense to go in this chronological order. Check if they're below 4, below 12, and below 55, and if they're not like this. But for example, if you were to say else if age is less than, if age is, like if you were to do this, for example, if you were to say if age is less than 55, then see out yes. And then else if age is less than 12, I don't know why I have this here. Then say with the parent, then else if age is less than 4, no, then finally not safe, of course. Now if you run the same program, definitely give us a different answer. Now let's analyze why. So we say our age is 2, and note that in else if statements, the second it reaches a value, let's say it terminates at this point, then I'll go ahead and stop doing the rest of the else if statements. Others will just keep going, right? But in this one, if you go ahead and run this, of course the answer should be no, right? But this one gives us yes, because this one evaluates if age is 55. It's like, well, it is less than 55, so we'll go ahead and we'll go ahead and run this piece of code, and I'll essentially skip to the end of this this if else sort of block. So essentially, this is a good reason why you should always order it in a proper order. Otherwise, your code will always it'll get really really messy. We can do another example with else if statements right here. So let's say you wanted to write a code that told you in the morning what it felt like outside. So you have an int temp. Let's say it's 50, right? And then of course you can input the temperature. You've learned how to input. And then if the temperature is less than or equal to 32, then you can output it's freezing outside, then else if temp is less than or equal to 50, say let's say chilly day outside, and then else if temp is less than or equal to 85, let's say a warm day outside, and then finally if it's above that, it's a really hot day outside. So we can go ahead and run this program. Temperature 50. It's a really chilly day outside. Now, of course, you know we can do an sin into temp, and then it'll ask us for an input. So we put in it's 87 degrees outside. It's really hot day outside. So now that we know a little bit of else if statements, you know that it might get buggy if you do it in this sort of order. Make sure the order goes right. We know the syntax. Let's go ahead and try this in action. So this will probably be the hardest problem that we'll solve today. And then we'll go into solving the homework after this. But we have a task that you have to input a speed. You have to tell our driver whether he should speed up, stay at his speed, or slow down. The speed limit is 60 miles per hour. And if the driver is within 5 miles per hour of the limit, they can continue with their current speed. Otherwise, tell them to speed up, slow down, etc. Give me a second. Right here, here's a task. So let's go ahead and take your time. Make sure everything works correctly. All your else if statements are in order. Everything works fine. We're gonna go ahead and give you guys 7 minutes for this. So it's been about 4 minutes. I'll solve in about three-ish minutes. Just want to make sure everyone gets enough time. Okay, so I'm gonna go ahead and solve this problem now. So we're gonna start off by inputting a speed. So we're gonna integer called speed. Go ahead and just input that. And now we need to make our if-else statements. So the speed limit is 60. The driver is within 5 miles per hour of the speed limit. They can continue their current speed. So I'll go ahead and do this. We'll do if the speed is less than 55, right? I'll go ahead and tell them speed up. Otherwise, if their speed is, oops, I wrote that wrong. Speed is less than or equal to 65, right? We should tell them to stay at their current speed. At your current speed. And then finally, if they're greater than 65, then you can say slow down. So you're going to run this. It asks us for a speed. Let's say we're going at 80 miles per hour. Oh shoot, that's the wrong one. Let's also slow down, right? Um, Now note that you could have solved this problem in a multitude of different ways. So you could have said the speed is less than 55, then you should speed up. And else if your speed is greater than or equal to greater than 65, then you should slow down. And then the else statement would be used essentially for the middle part. But any of the following work. There's multiple different ways of solving each problem, and any unique solution should always be celebrated. So now we're going to go into the homework problems from last time. Quick side note on the homework. The homework problems we designed, we planned to go over doubles in the last class. Some of the problems you might have not been able to solve with integers or the content that you knew from last class, but it's fine if you didn't. There's always a learning opportunity, and if you want, you can go ahead and resolve them from last class. So here's the first problem. I'll go ahead and copy it in here. It says write a program that calculates the area of a circle. Keep in mind that the radius should be inputted by the user. The only assumptions that are used below is that pi is 3.14, the area is pi r squared, and if the radius was 2, the area would be 4 pi. So this one didn't really require the need for uh, doubles, but if you use them, that's fine. If you didn't use them, that's fine as well. I can solve it both ways. We'll go ahead and comment this out as well. Okay, so we'll start off with here, int radius, send in the radius, and it says, so we're going to, we'll create an int area. Let's do radius times radius, just pi r squared. Then we just output the area is, we would have outputted area. Then immediately after, we can just output the string, the pi symbol, or we can just put pi view end line. So if you just go ahead and run the test case, or some comments in blocks. Let's see where I messed up on commenting. It's only 2. So I'll go ahead and ask us, we're going to run the test case, which was 2. Go ahead and run 2 of the areas 4 pi. You could have done it that way. Go ahead and try another one. Let's say 7, the radius is 7. REPL. Okay, it's back now. So yeah, if you go ahead and run this program, I'll ask you for the radius, put in 7, the radius for 9 pi. Now you could have also done this a different way. You could have gone ahead and made this a double. The radius times radius times 3.14, the value that he gave you earlier. The area is, and then you could just output it the area. You're going to run it. If you put in 2, give us a value of 12.56, which is 4 times 3.14, which seems right. You can go ahead and run it again. There it is, 153.86. So that was the solution for the first problem. You could have solved it using integers, not knowing doubles, but it's fine. So we'll go on to the next problem. The next problem is actually write code in C++ that determines how much a family has to pay for a ticket at the theater. So you could now that we know if else statements, you could have done an if statement like if kid, you could have done put $3.70, but we'll solve it the way that from the knowledge that we knew from last class. So you can do double, and we can do p kid, price of a child, price of an adult, price of a senior. So we'll go ahead and specifically ask us to be polite. Remember that. You can go ask them how many kids are watching the movie. And then, oh shoot, I wanted to find the values of p kid and all that. So p kid is equal to that. P child is equal to $5.67. P adult is equal to $8.96. And then P senior is equal to $4.56. Right, and then we need ints for number of people, right? And kid and child and adult and senior. And how many kids watching the movie and kid Then you can copy paste this for how many children. Children, how many adults. And how many seniors. And then we can just do double total cost. That just equal to, actually I should make this a double since we're sticking with doubles for this problem. We'll go over type convergence later. You can do p kid times n kid plus p child times n child plus p adult times n adult plus p senior times n senior. And then see out the total is, just output the value of total cost and say thank you for, just say enjoy the movie. We're going to run this program. Ask us how many kids. Let's say 2 kids, 1 children. How many adults? Let's say 4, and then seniors. Let's say 3. Total is $62.59. Looks like we forgot the space. And, you're just putting in random numbers. The total is $352. So that's the solution to the second problem. The third problem was, I'd say, probably a little more trickier since it had to do extensively with doubles, but it's okay if you didn't solve the problem. Go down here. I'm going to put in the third problem. So it's calculating tax from a payment. The tax is 1.6% in this instance. So I'm going to say int price, right, and then send in the price. Right, we should use doubles. We're doing we could have, let's say, like $4.99 for price. Send price, and then we can say double cost tax is just equal to the price times 1.06. And of course we see out cost tax. So let's say the price is $76, and total has to be $80.56. Now note that we could have done this all right here. You could have just done this part. So using the variable, you just done the same thing. And then if you put $78, it'll give us, or how many dollars it was, it'll give us the same value. So these were all the homework problems from last class. We have about 10 minutes left, so I'll go ahead and end the stream. I'll be monitoring the questions channel, so if any questions, feel free to ask them.